Alright guys, we are going on to our last section, which is 10.6 expected value. It goes along with learning target 4, which is determine the expected value of a random event. So let's first define what expected value is. It's the average value that can be found by multiplying the values of each event by its probability and then summing all the products, which doesn't make sense now, but I'm going to come back to this, or hopefully we'll come back to this during the video. It's basically the average or the mean of what you're going to get in an experiment. So it probably makes most sense if we just jump right to some examples after you get that down. Alright, so if we look at an example here, we have an animal shelter where there are 25 dogs and they're shown in the dot plot below. Each day the vet is going to randomly select a mother and check the health of her puppies. We're asked what is the expected number of puppies to be checked tomorrow. So we're going to find the average or the mean value of puppies checked each day. To do that, we're going to take the probability of getting each puppy. So there's going to be 4 out of 25 for puppy 2, and then we're going to take that times each puppy. Okay, so we'll start with the litters of 2. So from these 25 dogs, there were 4 dogs that had 2 puppies. So 4 out of the 25 had 2 puppies. That's 0.16. So if we take 0.16 times the 2 puppies, that's 0.32 is our product for getting 2 puppies. Okay, 3 puppies, there were 10 out of the 25 dogs that had 3 puppies in their litter. Okay, that is 0.4. Okay, so 0.4 times 3 gives us 1.2 as our product. 4 puppies, there were 8 dogs out of the 25 that had 4 puppies, which is 0.32 times the 4 puppies is 1.28. And then finally there were only 3 dogs that had 6 puppies out of the 25, which is 0.12% probability, or 12% probability, times the 6 puppies is 0.72. So if we add up all the different puppies, we're going to get on average 0.32 of the 2 puppies, 1.2 of the 3 puppies, 1.28 of the 4, and 0.72 of the 6. That's 3.52. So that means that we're going to get an average of 3.52 puppies each day. Now obviously you're not going to check 3.5 puppies, but that is the average number of puppies checked in a day. Okay, so it doesn't make literal sense in this instance, but so if you don't really understand what we did here, if you think about it as the total number of puppies, so we took 4 litters of 2 puppies times 10 litters of, or plus, not times, plus 10 litters of 3 puppies, plus 8 litters of 4 puppies, plus 3 litters of 6 puppies, all over the number of dogs, the number of litters that there are. So that ends up giving us 88 puppies divided by 25 litters. Still, that also sums to 3.52. Okay, so that is our expected value of getting puppies each day, of the puppies checked each day. All right, let's look at another example. Example B, a bag contains 1 blue marble and 2 red marbles. We're asked to draw a tree diagram picturing all the possible outcomes and the probabilities if you draw 2 marbles without replacement. Then we're asked to determine the number of red marbles you can expect to draw if you draw 2 marbles. So, starting out right away, we're either going to draw red or blue, right? So the probability that we draw red, so the probability of red first draw, so let's say this is first draw, well, there's 2 reds and 1 blue, so that's 2 out of the 3 marbles will be red. And the probability of drawing blue on the first draw is going to be 1 out of 3. So we have 1/3 chance probability of drawing reds and then, or of blues, and then 2/3 chance drawing red. from there, we have 2 marbles left, right? Because we only have 3 marbles. So the probability of drawing red first and then, or drawing a red again, red second, after drawing red first, so the probability of red at second draw after or given red 1 would be, well, we have 1 red left and 1 blue left if we've already drawn a red here. So that's going to equal 1/2. And the probability of drawing a blue on draw 2 after we've already given a red draw 1 is going to be 1/2, because there's a red marble left and a blue marble left if we draw a red the first time. Now if we draw a blue the first time, then the probability that we draw a red the second draw, given that we drew a blue our first time, well, there's only 2 marbles left and they're both red, so that's 2 out of 2. The probability that we draw a blue the second time, given that we drew a blue the first time, well, there are no blue marbles left, so that's 0 out of 2. So there's 4 different outcomes here, and this one's kind of an outcome, but it's really not. So we won't even really need to think about it. Really, there's 3 outcomes. So let's talk about what this probability is. The probability that we get a red drawn on the first one and then another red drawn on the second one would be one of these 3 outcomes. So we have a 1/3 probability that we're going to get a red and then a red. That's also 2/3 times 1/2 is 1/3. Okay? Again, 2/3 times 1/2, the probability that we get a red the first drawn and then a blue the second draw would be 1/3. And then finally, the probability that we get a blue the first draw and a red the second draw is going to be 1/3 times 1, which is 1/3. And it would make sense, since we have 3/3 here, that the probability of getting a blue the first draw and a blue the second draw is going to be 0. So that's all the different outcomes, okay, and their probabilities here. Now let's talk about the number of red marbles you can expect to draw if you draw 2. So we're going to average the number of red marbles we're expecting to draw. Okay, so let's draw another table, kind of like our puppies table. So we have the outcomes, the probability, and the product. Okay, so the outcomes here, we can either get 0 marbles, or 0 red marbles, which we really can't, but we'll put it in the table. We can get 1 red, or we can get 2 reds. Okay, now the probability of getting 0 reds is 0, because it can't happen, which means 0 times 0 is 0, so it can't happen. The probability of getting 1 red would be, here we get 1 red, and here we get 1 red. So that's 1/3 plus 1/3 is 2/3. 2/3 times the 1 red marble is 2/3. And then the probability of getting 2 reds is just this 1 chance where we draw a red and then we draw another red. That's 1/3, so it's 1/3. But that probability, 1/3 times the 2 red marbles, is 2/3. So we have a product, the sum of our products here is 2/3 plus 2/3 is 4/3. Okay, so that means the expected value of getting a red marble would be 4/3, or 1.3, about 1.3 red marbles, which I know, again, doesn't make a lot of sense, but it's closer to 1, so you would err on the side of 1 maybe. Why don't you guys try this? From that example that we just did, find the number of times you can expect to draw a blue marble if you draw 2 marbles. So in the same way that we made this table for the red marbles, you can go ahead and make that table for the blue marbles.